All right, so we're going to look at sketching angles today in degrees. And then once we understand how degrees work, because most people understand degrees because you've been working with degrees since like elementary school, then we'll review tomorrow. And then on Friday, we're going to transition to what's called radians, right? And then as we get further on into the trig, we're going to kind of move away from degrees and just solely work with radians. Because radians are actually going to be easier to work with all the calculations and stuff, easier than degrees. But for now, if we understand how degrees work, then we can just transition into radians when we get there. All right, so when we want to sketch an angle, we call this standard position. An angle is made up of two rays, and they come together at a vertex point. So we're going to take that vertex point where the two rays come together and put it on the xy axis, and we're going to put it at the origin, so 0, 0. So we're going to keep the one ray right here on what's called the initial side, so it's going to always stay here on the x-axis on the positive side. This other ray, it's called the terminal side, that's the one that's going to rotate. Okay, and you kind of see how it rotates kind of like around a circle. And so that's going to give us our angle when we sketch it. Now, it can rotate in the positive direction or it can rotate in the negative direction. So we're going to get positive angles and negative angles, and we're going to be working with both. All right. So positive angles are always going to be rotated in the counterclockwise direction. So counterclockwise. All right. So when we sketch this, that's our initial side. So that's the ray that never moves. And then we can rotate the terminal side. So let's say we, put it right here. Now, if we want to state that this is a positive angle, we rotate it in the positive direction, then we have to put a direction arrow on it. So it looks something like that. Right? So that's how you would sketch a positive angle. A negative angle is going to go in the clockwise direction. Okay. And so there's our initial side. And so if we want to say that this is a negative angle instead of a positive angle, then we show the direction that we rotated the terminal side. All right. So not putting this direction on here is important, because if all we do is draw this in here, we don't know what the actual measurement is. Were you talking about the positive angle, or were you talking about the negative angle? All right. We also need to know the quadrants of the x and y axis, because the angle is going to fall in one of those four quadrants. So when we name the or number the quadrants, we go in the counterclockwise direction. So this is always quadrant 1. This is quadrant 2. We usually use Roman numerals. Quadrant 3, and then quadrant 4. So the quadrants will never move. Okay, it doesn't matter if we're talking about a positive angle or a negative angle. The quadrants always stay 1, 2, 3, 4 in the counterclockwise direction. Now, we also want to know some reference angles to help us sketch these angles out. So 0 degrees is right there. So when the two rays fall directly on top of each other, it could be a 0 degree angle. That's how you'd sketch it. 90 degrees would be up here. 180 degrees directly across from the 0 degrees, and then 270. And then if it does one full rotation, then you're back at 360 degrees, which is where 0 is. Now, these degrees can rotate in more than one time, so we can sketch angles that are bigger than 360. We would just use concentric circles to show that it's rotated more than once. Now, if we go in the negative direction, okay, so this is 0 degrees. In the negative direction, this becomes negative 90. Okay, negative 180, negative 270, negative 360, and so on. Okay, so just understand that when you go in this direction, that's a negative 90 degrees, which is the same position where positive 270 is, and so on. All right, so let's go ahead and sketch these angles out real quick. All right, so 135 degrees. So the first thing we want to do is figure out what quadrant is 135 degrees in. 2, good. So when we sketch this, okay, here's our initial side. Quadrant 2 is where 135 is going to fall in, somewhere between 90 and 180. They don't have to be exact, but get kind of close. And then we want to put our direction that we rotated, and so that's positive 135. So something like that is great. Okay, Ryan, you getting it? Good. All right. Negative 200. So when we rotate this at negative 200 degrees, what quadrant would it fall in? No. Okay, so here's 0. That's negative 90, negative 180, negative 200 right here, because negative 270 is up here, and so it's going to be in here. Okay, and that's still quadrant 2. It hasn't changed. The quadrants never changed. It's still 1, 2, 3, 4. Right? But because it's a negative, you have to go in the negative direction. All right. So it's going to fall right here in quadrant 2, a little bit above 180. Okay, and we are going in the negative direction, so we've got to rotate and show the direction. All right, 450. Okay, so if we rotate this 450 degrees in the positive direction, where would it fall? All right, so this one's kind of tricky. It's going to actually fall right here on the 90, because you go 360, and then you got to figure out, well, how much more do you have to go from 360 to get to 450? So you need another 90 degrees. So it's not going to fall in a quadrant. It actually falls on an axis. It's crazy stuff. All right, so it's actually going to fall right there. But to show that this is not a 90-degree angle, this is a 450-degree angle, we use a concentric circle that looks like that. So you start small and get bigger as you rotate. All right, so again, check your calculator. 360, okay, plus another 90 would get you 450. All right, let's try one more of these. Let's try number 4. Okay, we're gonna have to get crazy on this stuff as long as you get the basic idea of sketching an angle. Negative 580. Let's do that one. Negative 580. Negative ones usually are the hardest ones for people. All right, so we know negative 580 is going to get us more than one time around. Okay, so we're starting there. So in the negative direction, that's negative 360. All right, so how much more do we need to go to? Okay, so we have to go another 220 degrees. That's 180. 220 take us up here. That's quadrant 2. Does that make sense to everybody? No. Okay. Do you understand why we're going in the negative direction, first of all? Because it's a negative angle. Negative angles tell you to have to go in the counter in the clockwise direction. We're on 4. Okay, so we know that 580 is more than 360, so we have to go more than one time around. We already know that. So if you know multiples of 360, okay, 360, 720, that kind of thing, you know that we're not going 2 full times around. We're just going 1 plus another part, okay? So if this is 360 one time around, just take 580 minus 360. That'll tell you how much more you need to go to get to 580. Right, so that means we need to go another 220 degrees starting here. So that's negative 90, negative 180. So another 40 more degrees will get you negative 220. Yes? Getting better? Okay, good. All right. Let's move on. All right, coterminal angles. Coterminal angles are angles that share the same terminal side, okay? So they start and they stop at the exact same place, except their angles are actually different measurements. So for example, 135 degrees. If we draw in a 135-degree angle, what quadrant does that fall in? Second. Okay, so here's 135 degrees. A coterminal angle would start and end at the exact same spot. So we could draw in this angle just in the negative direction. All right? So this angle going in this direction is called coterminal to 135 because it starts and ends at the exact same spot, but the angles have different measurements. So if we knew this was 135 in the positive direction, what would this be in the negative direction? Okay, negative 225. What? Okay, so I drew in the 135. Okay, so if I want to find a coterminal angle, I can draw another angle in here that starts and ends at the exact same spot as this positive 135. It's just going to go in the negative direction. So this angle, negative 225, starts and ends at the exact same spot as 135. You see how this angle looks exactly the same as this angle, it's just the direction arrow is the only thing that's different. All right, so this is why it's important to understand how directions work. See, if I drew this angle right here, yeah, turn that off. All right. Do you see these two angles? If I just draw them like this, how do we know what their measurements are? We don't, okay? But I can see that they both start and end at the exact same spot. So if I draw in the direction arrow, okay, now I know their measurements are different, okay? So this I know is positive 135. This would have to be negative 225. Okay, if I know the positive angle, then I can go in the negative direction, just subtract it from 360, and I can get the other one. So it's not necessarily they're adding up to 360, it's that they start and end at the exact same spot. Their angles look exactly the same. Okay? So what if I draw in the exact same angle, but now I draw it like this? So what would this angle be then? It would be 360 plus an extra 135 degrees. So that angle, whatever that is, 360 plus 135, 495. So a 495-degree angle starts and ends at the exact same spot that a 135 and a negative 225 start and end at. It's just the measurement's different. Okay, so all we're saying is the coterminal angles, they start and end at the same spot, except their angles have different measurements. Okay, so there's an infinite number of angles that can be drawn this way, okay, that start and end at the same spot, except they're all just deals with direction that you're drawing the angle and concentric circles. So you can go around 2 times and then start here. You can go around 3 times. This one and this one always are going to be in the same spot, okay? But the angles are different. So all we have to do is to find coterminal angles, we can kind of just use this right here. We can add and subtract multiples of 360 degrees. All right, so let's see how this works. So find 2 coterminal angles, one positive and one negative, for each of the following. So for 60 degrees. So if I draw in a 60-degree angle, there it is right there, that's 60. So if I want to find a coterminal angle to 60 degrees, I can take that 60 and add 360 to it. That's 1 time around, okay? So that would look like this. So what's the measurement of that angle? If I take 60 and add 360, 420. Right? So this angle right here is a 420-degree angle. It starts and ends at the exact same spot that the 60 degrees is. So we say that 420 degrees and 60 degrees are coterminal to each other. They start and end at the exact same spot. Right? Now, if I want to find a negative one, I can take 60 degrees and subtract off 360. That would be negative 300 degrees. All right? If I take a negative 300-degree angle, okay, and I want to draw it, it would look like this. So here's negative 300 degrees. It's starting and ending at the exact same spot that the 420 and the 60-degree angle is. So all three of these are coterminal together because they start and end at the exact same spot. That's the one they give you. So they give you the 60, and they're asking for one positive and one negative coterminal angle to 60 degrees. So we found a positive one, 420, and we found a negative one, negative 3. All right, so let's try 210. All right, so if we draw in a 210-degree angle, so it would look something like this. If I want to find a coterminal angle, okay, so I can take that 210 and add on 360. That would be 570 degrees. So 570 degrees, if you were to sketch it out, it would look something like this. It's still starting and ending at the exact same spot that the 210 did. Well, what would a negative one be? Well, we take 210 and subtract off 360. So that would be negative 250. Negative 150, that's what I meant. So if you were to sketch out a negative 150-degree angle, it would look like this. So it's starting and ending at the exact same spot that the 570 did and the 210 did. So if we had to find or state what a positive and a negative coterminal angle to 210 would be, you could say 570 and negative 150. All right, so now let's go ahead and find one positive, one negative for each of these. All right, so starting at 390, okay, you could add 360. 750. That's a positive one. We could take 390, subtract 360. That would be 30. That's still a positive one. So for the positive one, you could give 750 or 30, but we still need it to get negative. So that means that we have to subtract off another 360 to make it negative. So that would be negative 330. So negative 330 is our negative one. You could give 30 as your positive or 750. Okay, there's an infinite number of answers you can give. You just have to give one positive and one negative. Okay, so if it doesn't go negative by subtracting 360, you got to do another 360. If you're starting off with a really small negative number and you add 360 to make it positive and it doesn't make it positive, then you have to keep adding 360. So you have to do it multiple times until you can get it to be positive and negative. All right? All right, so find one positive and one negative for the rest of those, 10, 11, and 12. So for 12, because 1160 is a really big angle, subtracting 1360 off is going to get you at 800. That's a positive one, and you can give that answer. You can subtract off another 360. That would get you at 440. That's still positive. You could give that answer. Subtracting another 360 is going to get you at 80. That's still positive. You can give this answer. All right. So you can give any one of those three as your positive one. Now, if you subtract off another 360, we're going to be at negative 280. There's our negative one, and we can stop there for our negative one. Right? So positives, again, you can give any one of those. Doesn't matter which one, but you have to do it multiple times to get to the negative. Okay, that makes sense? Add 360, subtract 360. Get a positive and a negative. Sometimes you have to do it more than once. Okay. Last thing we're going to look at is what's called the reference angle. We talked about reference angles when we're setting up, when we have a triangle, and we had to set up SOHCAHTOA to figure out are we using sine, cosine, or tangent. Okay, I said refer to this angle, that's your angle that you're using, and then figure out what's opposite, hypotenuse, adjacent. All right, so this is our reference angle is going to be always an angle that's less than 90 degrees, so between greater than 0, but less than 90. All right, and it's always formed by where the terminal side ends and the x-axis, the horizontal line. Right? So here's our quadrants 1, 2, 3, and 4. So if the angle falls in quadrant 1, this is called the reference angle right here. This angle will be between 0 and 90 degrees. If the angle falls in quadrant 2, this angle right here is called the reference angle. Right? So you figure out what this angle is, and then we want to know how much more do we need to get to the x-axis. This is our reference angle. This will be between 0 and 90. Now, there's a formula that you can memorize. Okay. So in quadrant 1, that angle right there will be your reference angle. If it falls in quadrant 2, this formula you can use is 180 degrees, subtract off the angle that they give you. Okay. So that'll be your reference angle. So you can take 180 degrees minus whatever the angle is. So let's say this is a 120 degree angle right here, 120. Then this angle right here has to be 60. Right? So the reference angle is 60. So if you take 180 minus 120, you're left with 60 degrees. That would be this angle right here. All right, if the angle falls in quadrant 3, all right, so this is our reference angle right here. And so we can use a formula, take the angle and subtract off 180 degrees. So it's just the reverse. And then if it falls in quadrant 4, then we can take 360 degrees and subtract off the angle. So for example, let's say we sketched a 300-degree angle. 300 degrees would be in quadrant 4. This angle right here is our reference angle. So 360 minus 300, you'd be left with 60 degrees, and that would be the reference angle. All right, so if we sketch a 150-degree angle out, so we know it falls in quadrant 2. So here's 150. This is the reference angle right there. So what would that reference angle be? 30, right. Okay. So again, you could use the formula, 180 minus 150 if you wanted to. Or you can just see what do you have to get to, what do you have to add to 150 to get to 180. We're trying to get to the x-axis. All right, 210. So 210 is going to fall in quadrant 3. All right. And so we want the reference angle, which is right there. So what would that angle be? 30. All right. Or you can take 210, which is the angle they give you, subtract off 180, and that's 30 also. All right, so 390 would fall in what quadrant? Okay, 1. All right, so it would look something like this. That's 390. So our reference angle is right here. So what would that angle be? Has to be less than 90, so what would that angle be? 30. All right, and then negative 405. Right, so going in the negative direction, that's negative 360. And then that means we have to go another 45. So there's negative 405. Our reference angle is right here. So what would this angle be? 45. All right. So again, we had to go 360 plus an extra 45 to get to negative 405. This is our reference angle. That's 45 degrees. That's why sketching it out sometimes helps. Or, you can memorize some of the formulas. All right, so that is all we're going to do today.